Tonight we're going to have a program on the Arecibo Radio Telescope, its history, collapse, and future. And of course, this is a very timely subject since it just recently suffered extensive damage as the suspended observation platform collapsed into the dish. And we have two speakers. We're pleased to have Stan Kurtz with us tonight, who's a research professor at the National Autonomous University of Mexico. He got his PhD in physics from the University of Wisconsin and has worked several times at Oak Ridge National Laboratory. He's currently pursuing research at various facilities, including the VLA in Socorro, New Mexico, the GBT in West Virginia, until recently the Arecibo 1,000-foot telescope in Puerto Rico. He mostly studies high mass star formation, molecular clouds, and molecular masers. He's also become involved in several radio instrumentation projects. The second speaker is David Fields, who probably needs no introduction to most of us, but he is the director is the president of ORION. He's also the director of the Tamke-Allan Observatory. He got his master's and PhD in condensed matter and materials physics from the University of Wisconsin, and then worked at Oak Ridge National Laboratory for 24 years. He's also been a guest scientist at the German Federal Health Office and represented the International Atomic Energy Agency in Brazil, and has returned there to work on federal facilities and present graduate level courses on environmental transport, human exposure, and risk evaluation. He's also consulted with NASA and done simulations of the performance of spacecraft radiation shields. He's also has current research interests in electromagnetic transmissions through magnetized plasmas and in Dyson dots. So with that, I'll turn it over to whichever one of the two of you will start speaking first.
Well, that's easy done because Stan knows a lot more and he's got a lot more to say. So I'm going to kind of do the introduction. And well, I wrote up a really short bio and sent it in to somehow the old one got picked up. So I don't think there's too much lying in the long one, but it goes on and on. Anyway, I hope you all are doing well and surviving 2020. I've been told 2021 is guaranteed to be better. So let's hope that's right. I'm going to do a shift into PowerPoint here. Okay, so basically, we're going to look at what's happened with our Arecibo facility. And what this says, caution, this is a disturbing topic. And it's one of these warnings you get when you see things sometimes on a video that caution, this may not be appropriate for young eyes. Because it's not a happy story, really, in the end. What I've written down here for those of you that don't see it well. Okay, what this says is recent events at the planet's most sensitive half-frequency radio telescope, the planet's primary asteroid defense facility, the planet's most powerful radar facility, and the planet's second largest radio telescope is what we're going to talk about. And there's a link. Now, I don't want to start off with a link. We're not going to see that. What I'm going to show you is the electromagnetic spectrum. And this is a view of the spectrum all the way from radio, microwave, infrared, visible wavelengths and frequencies to gamma ray. And the region that I'm going to show you here, radio, microwave, all the way to infrared, if we touch in the sub-millimeter region, that's radio astronomy. And just like we can use infrared, visible, ultraviolet, X-ray, gamma ray telescopes to do astronomy, we can also choose to do astronomy in the radio wavelengths. And the amount of physics that one can investigate is significant. The amount of the discoveries in the last 30 years, 40 years, 50 years, using radio astronomy have actually eclipsed, I don't know if I should use that word here or not, but have actually overshadowed, in a way, another optical term, what we know about what we discovered with optical astronomy. It's pretty impressive. So Arecibo covers the microwave region, and it actually is the highest frequency big radio telescope we have, even doing better than the new Chinese fixed dish radio telescope. So Arecibo is a very significant facility. Radio astronomy has been with us a long time. I'll get some blowback if I claim this, but I think that Tesla probably picked up, if you go back and look at the notes, probably picked up some radio signals that were extraterrestrial in origin as early as 1899. It's a whole topic in itself. Most people consider radio astronomy started with the work of Karl Jansky, and he was working for Bell Labs investigating radio noise. He built a very interesting system in 1931, 1932, and demonstrated that a lot of the noise that was interfering with transatlantic telephone calls actually arose from the Milky Way. It was one over F noise, it was cyclotron noise, and so forth. And he timed it very well. He demonstrated the direction. It was pretty conclusively demonstrated that the Milky Way was what was important there. Okay, so 1932 to 1937, there was not much done. Radio astronomy was not recognized as worthy, but Grote Reaper in 1937 finally got his system working, and he had built a dish system, and he was able to actually start mapping the sky. So this was rather important. You could actually get data, you could examine the data and determine what was emitting the signals. And it started getting some interest. So this has nothing much to do with radio astronomy, except some people tend to think in terms of soccer and football. So look at the size of the field. One could actually build a big radio telescope that size and thereby intercept more of the radio signals. So bigger is better in that larger areas are better light buckets. If you go to Green Bank, you can see the GBT, the Green Bank Radio Telescope. This is what you can do if you get away from the concept of a fixed dish. I mean, from an agile dish. Green Bank is wonderful. It's an agile dish. It's a very, very good frequency range. But if you go to a very large dish, such as on the upper left at Arecibo, or the one in China, you can intercept more of the signal. And so just for comparison, up in the little left-hand corner of the screen is the fabled, somewhat uninspiring football field. I don't get into football, but by comparison, this is the size of the Arecibo facility. And it's several football fields in size. Pretty amazing. This 1,000-foot diameter radio telescope is a world-class facility, and until recently, the biggest in the world. It is still, as I went into earlier, still the best, at least until recently, the best for many purposes. Bigger than what you see in the upper center from Green Bank, bigger than the lower right, what the Russians have. It's a very large facility that the Russians have, but the collecting area is not so great. And the FAST radio telescope in China is a truly wonderful instrument. So it's pretty impressive. It's the primary research facility, museum, and outreach facility of Puerto Rico. So that gives you some idea of its importance to Puerto Rico. And the location on the island of Puerto Rico is here. If you want to visit it and you go the conventional route, you don't take the time to go in via ship, and you don't try to do something dramatic from above. You fly into San Juan and take the bus or other conveyance out to the remote facility here in the karst region. So there you find, as you'll find in all karst regions, you find the sinkhole, and the sinkhole has been coated with reflective material, and you have the Arecibo facility. In 2004, the Society of Amateur Radio Astronomers had a regional meeting there, and it was really inspirational. Wanda Diaz is there, and Carmen Pantoja, they arranged it for us, and a lot of the people are still in the area. I'm sure some of you recognize Charles Osborne, Rodney Howe, Lisa Tackett, and Mary Watson died in 2005. Karen Jensen died a few years later. But one of my friends that was there, I'm here, was John Manoni. And I asked John if he would share a poem he wrote, because we all looked at Arecibo, and I'm sitting there smiling and thinking, wow, I'd love to work with this facility. And they were kind enough to let us do that. Rodney Howe and I, for example, Rodney's here, were able to sit at the controls of the Arecibo facility and look at the approaching and receding edges of the Andromeda galaxy. So that was just delightful. So John is here, and he doesn't have video. You can see his picture. But John, I wonder if you'd like to share your poem with us, because the poem, John saw something else. John saw the dish, and he saw a spider web, and he looked at the ALMA facility of multiple receivers in the Gregorian platform, and he saw the 8 eyes of a creature.
That's great, David. I appreciate the invitation. And is it possible to share screen?
Do you want to read it, or shall we read it?
You know, I'll read it, but just a little bit more on the history. It's been revised, and since then it has been published in Azahades, which is a Spanish-English journal. Wanda Diaz had helped me translate this into Spanish. And so we're co-published, her with the translation and mine with the English. And this is the poem. Outside the control room at Arecibo Observatory, colors gloss its web as oils coat a raven's quill, red with blue and violet sheen, separate clean as oil from water. Silk stretches with strength of steel, anchors between the karst and tangerine tree. Almost unnoticed amidst the tropic green, this star catcher in the middle of the courtyard, like a fragile bubble film betrayed by shimmer, deformed by wind, but with reticulate design. And in its intricate world, its lord tethered, all eyes searching. I wonder how it is probing its universe, my universe. And as you know, most spiders, I don't think all of them, have 8 eyes. And when I went to tour the Arecibo facility with its 8 different receivers in that one dome that shines down on the main dish, it's like each it's like a different eye. And so that's what inspired me, the macrocosm and the microcosm of these 2 creatures. Anyway, that's my poem.
Thank you, John. I believe the words were a little bit different that I remember, but
yeah, just a little. It's been improved.
Yeah, that's great. That's great. What I'm going to do, and I'm going to try to show you what's going on there at the link. Now, this was a fantastic facility. Okay, so this is a tragic thing. This is the collapse of the platform that's normally suspended over Arecibo. It looks gossamer. It looks like a small facilities. Actually, it's a steel structure stabilized by lead, and contains the Gregorian here it's actually a very large room containing a megawatt radar system, fantastic receivers, cryogenic facilities to cool down to in some points liquid helium temperature. And the total mass of this thing has a weight of 900 tons. Now, it's just an amazing feat of engineering to build it, and a great tragedy that you're going to see here, the end point of a project that to most people, and what we see takes a few moments. had several,
Heartbreaking.
yeah, several cameras. Did you get the audio from this? This is drone footage, actually.
It's not very good audio.
Okay, I could have improved it, but the audio is not important. But you get the idea that this occurred in a matter of less than a minute. And that's not my viewpoint. My viewpoint is that the process took 14 years.
Was the camera on it because it was known that it was going to collapse?
Yeah, the camera's on it because it the first cable break was in August, the second cable break was in November, and they anticipated that it was going to be shut down or that it would fall. And actually it did. You've just seen the collapse. So 14 years brings us back to 2006. In 2006, I'll go over this briefly. In 2006, we were 4 years into a disastrous invasion of Iraq, which grew and grew. And in 2006, the government announced that research would be cut back significantly. And in particular, astronomy research would be cut back 15%. So 15% at a time when the new regions of the sky were very important. The regions that could be seen from the Atacama Desert in Chile and Argentina. That work there is extremely important. Higher frequencies, better resolution. And Arecibo was very important, but it was all the old science. So starting in 2006, the budget just wasn't there. And I think that's why the engineering, which had been just world-class, and maintenance took a hit, which culminated in the cable breakage in August. So this marvelous facility, and it was known worldwide, pictured in all astronomy books, an inspiration to scientists, and very heavily used, went in a bad direction. So how is this going to work out? And I don't know. I don't know how it's going to work out. Something I've been working on is one approach to maybe some recovery, where we go from what we see here, a very functional system, to a different type of functional system, not with an 100-ton platform, but with a stabilized convex hyperboloid reflector here, and a different type of central receiver and radar facility located pretty much at ground level. But that's hand waving. So this is an outline. I want to depart from that, turn it over to Stan, and really get away from the hand waving, go back to some of these major accomplishments. And I could go over them, but I think Stan will go over them in more detail. Is that okay, Stan?
Sure. Yeah, I'll take over from here. And
okay. Thank you, Stan. Stan and I've known each other for a long time, and he's worked in a lot of places and done some great things. So thanks for agreeing to work with us on this, Stan.
Well, I had a great supervisor when I was getting started one summer at Oak Ridge. So I think I have a big debt to pay there.
Send tequila.
So as David mentioned, I'm going to talk about some of the key accomplishments that have happened with the telescope, and I'll also talk a little bit about who's responsible for its collapse and make a few other comments along the way. So forgive me if it isn't a terribly organized talk, but hopefully it will be somewhat interesting and enlightening at various points. And to start with, I'd like to mention that there is a precedent for what we saw at Arecibo, much closer to home, in fact. Many of you may recognize, well, actually you may not recognize this antenna because many of you probably never saw it in this state. So this was the 300-foot telescope at Green Bank, which was built in the early 60s. One of the first radio telescopes that built in the US. It was only intended to have like a 10-year lifetime, but it lasted a lot longer than that and produced some amazing science, kind of like Arecibo did. But then in the late 80s, early 90s, somewhere in there, a bearing right in here in the main yoke, there were two of them supporting the entire weight of the dish, and one of them broke, and this was the result. They say that the pile of steel was live for 3 weeks afterwards, kept shifting and collapsing. So here it kind of didn't do too much damage to the building, but you can see what happens when you don't maintain a telescope adequately. But thankfully, in this case, the state of West Virginia had one of the most senior senators in the country, and he was a very powerful man. I think maybe someone can correct my misquote here. He at the time said something like, or he asked NRAO how much it would cost to replace the antenna, and they told him however many millions, and he just laughed and said something like, I only think about billions, not millions, something to that effect. And so West Virginia got this new antenna. Very nice. I'll mention a little bit later on just how much it cost, but you know, one can have a phoenix rising from the ashes of a collapsed telescope. So there maybe is hope for Arecibo as well. Hopefully something nice will come out of that. So, oh yeah, before I launch into some of the discoveries, this is a YouTube link that I'll show you some pictures of in just a moment. And if anyone wants the link later on, I'll send that by email or something. One of my main collaborators actually worked at Arecibo for several years, and then he was on the faculty at the University of Puerto Rico before he eventually went to the VLA. And one of his master's students while he was in Puerto Rico is this fellow here, Esteban Araya, a Costa Rican fellow, who now works at the University of Western Illinois. And Esteban has been very active at getting Illinois students involved in observing at Arecibo. In the picture here, he took a couple of students down with him. So this is the control room that you're seeing at Arecibo. And he also had some students back in Illinois who were connected over the internet. And they just set up a little cell phone to record what was happening during their 2-hour observing run. And so the first 45 minutes is kind of boring because they're just kind of getting things set up and whatnot. But then at about the 45-minute mark, they really start doing the observing, and Esteban is explaining to the students about how you point the telescope. And then once they start taking data, he explains some of the astrophysics behind the sources. So I'll jump through, let's see, I'll just take them in order here, although these are just screenshots that I took out of that YouTube video that you all can look at. Here you're seeing some of the screens that come up on the Arecibo control computer. So these are, in this case, they're doing data reduction. So the red and the green are the two different polarizations, the perpendicular polarizations of the radio waves. And here they've detected a spectral line. I think maybe in one of the later ones it comes up even stronger. So at this point, they're not controlling the telescope, they're actually looking at the data. And then if you zoom in on some of these windows, you can see the commands that they're using to to do the data reduction. Here's a somewhat stronger detection. And I do not remember if this is a radio recombination line, which is a very highly excited hydrogen atom. You know, in school, they have us calculate the wavelength when the electron jumps from level 3 to level 2 and so forth. But hydrogen actually can have electrons up in levels of hundreds. And so it might jump from level 167 to level 166 in the orbit of the electron. And the energy difference between those two levels is very small. So the photon that comes off as a result is low energy, and it's in the radio regime. And so radio recombination lines like that are one thing you can observe with Arecibo. In this case, it might also be a molecular line from a molecular compound that they were looking at, but nice sharp detection there, very, very strong detection. So you can see some, I mean, there's any radio telescope control room has lots of monitors around showing all kinds of information. You see one in the background there. Esteban and his student are looking at a couple of screens in their foreground that we can't see. Here Esteban is explaining something to the students back in Illinois who are watching over the internet link. The students here are controlling the antenna. More explanations, more data, and I guess that's it. I did have a couple of the windows that are covered up here show you how the telescope is controlled, how you point it and so forth. And I don't show the screenshots here, but if you go to that YouTube link, you can see it all there. So if you can still get the experience of observing at Arecibo if you recorded for posterity in that video that Esteban did. Well, I'll go back to my PowerPoint presentation then. So I made just a quick list here of some of the key discoveries that Arecibo has made over the years. Obviously, this is my personal choice. Other people might come up with a slightly different list, but I think I hit some of the most exciting and important ones here. The first confirmation that pulsars were neutron stars came from Arecibo. They observed the Crab pulsar with its 33 millisecond rotation period, and that was really the confirmation that pulsars were these rotating neutron stars. And Arecibo's done a lot with pulsars. Another finding later in 74 was the discovery of the first known binary star system, where both stars in the binary were pulsars. So it was discovered there, and then they continued to observe it over a number of years and saw that the period of the orbit was changing, slowing down, and that was evidence that the system was emitting gravity waves and losing energy by generating and emitting these waves. And ultimately that was worth a Nobel Prize in the early 90s. They discovered the first millisecond pulsar. Some pulsars later in life can accrete material from a nearby companion star, and that spins them up. So they start to spin a lot faster. And those pulsars provide a very high precision clock that can be used for lots of different purposes, one of which is to detect these gravitational waves. And the GBT, in fact, is doing a lot these days. Nanograv project, observing hundreds, maybe thousands of pulsars in these so-called pulsar timing arrays. And when a gravity wave passes through the galaxy, by general relativity, it changes slightly the clocks that these pulsars are. And by very carefully measuring the the deviation of these pulsars, you can tell that a gravity wave has gone by. And although anymore extrasolar planets are mostly done with, you know, optical telescopes and infrared telescopes, the very first ones were discovered around, well, their star was a pulsar, a neutron star, and they were discovered at Arecibo. So the first extrasolar planets were discovered there. More recently, there's been a lot of excitement about these FRBs, these fast radio bursts, that very short, very intense pulses of radio emission, which sometimes repeat and sometimes don't. And they still aren't very well understood, but we've made a lot of progress in recent years. Actually, there's a nice little sidelight here. I'll be quick about it, since I don't, how much time do we have? And David, what time should I be winding down here? You're muted, but I'll take that to mean I have all the time I want. Some of you probably heard about this. There plethrons, I kind of forget the name of it. They were first discovered in Australia, these strange pulses of emission. And turned out there were a lot of them that happened around noon local time. And what they finally tracked it down to was that if you open a microwave oven door while it's still running, it will generate a broadband microwave signal that covers quite a few different frequencies. And that was a radio frequency interference that they were picking up with the 64-meter Parkes telescope that was making the early studies of these fast radio bursts. And that injected a lot of confusion for a while, because some of the fast radio bursts were real. They were astronomical events very far away, but others were just generated in the kitchen of the observatory. And it took them a while to separate the two. But at any rate, at Arecibo, they detected the first one that repeated, that came multiple times. And that was important, because some of the early models, the theories to explain these very powerful bursts, is that it was some kind of catastrophic explosion event that didn't leave anything behind. But if it repeats, then clearly something was left behind. And so in one fell swoop, they could rule out a lot of these theories that they had been considering. Astrobiology, there have been several upgrades of the Arecibo telescope over the years, and one of them allowed it to go at least to 10 gigahertz, maybe up to 14 gigahertz. And that's important because as you go to higher frequencies, there are more molecular transitions that you can detect. There are few at the lower frequencies, but as you go to higher and higher frequencies, there are more and more molecular lines that you can detect. And I'll just put in a little footnote, not to be, well, we have a saying here in Mexico, crowns over the dead. You don't say anything bad, or I guess you have it in the US too, don't speak ill of the dead. But I will very briefly. Arecibo never took full advantage of their high frequency ability. It's like the observatory had this mindset that they worked at L and S band, and that's where their contribution was going to be. And they didn't fully exploit their C and their X band capabilities like they should have. I think they would have discovered a lot more in terms of this astrobiology and astrochemistry if they had a little different vision there. But they were discovering lots of other great things anyway. Planetary science, they made fundamental contributions to our understanding of Mercury and Venus, the moon, making radar maps of the surface, determining the rotation periods. They showed that the Venus has this retrograde rotation opposite to the direction that one might expect. This perihelion advance of Mercury, that's been known for many decades. It was considered the confirmation of Einstein's general theory of relativity. But in the early 70s, Arecibo made exquisitely precise measurements of that to provide really nice confirmation of that theory. They discovered ice on Mercury. In terms of asteroids, there's this Yorp effect. I forget Y, O, R, and P were the 4 researchers. I don't remember their names, but it's kind of a bizarre effect that due to radiation pressure of sunlight on the asteroid, and then as the asteroid emits thermal radiation, infrared radiation, there's a radiation pressure involved there as well. And the combination of these two can produce a torque and change the rotation of the asteroid. And so at Arecibo, they confirmed that effect. As many of you know, Arecibo actually was not built for astronomy. It was built for atmospheric and ionospheric studies. And so in the 70s, one of the big uses was to study the ionosphere, the D and the E layers, that they would heat up with their radar signal. And then after it heated up, they could observe it and watch it as it cooled back down and thus study its properties. They were the first detection of this ionized helium layer in the ionosphere. Fairly recently, Puerto Rico has tropical storms. They were able to measure the perturbations in the ionosphere caused by those storms. And although a lot of these big discoveries came back in the 60s and 70s, you know, as recently as 2015, 2016, they've made important contributions. And the one I picked out from 2015 was the smallest ever near-Earth asteroid. It's about 5 times the distance to the moon. So what, about a million kilometers or so, and it's only 2 meters in size. I mean, that's, to pick up an object that small, I mean, that's the size of a person, 5 times further away than the moon. You know, that, you can only do that with a telescope like Arecibo. And in 2016, they helped rescue the Indian spacecraft that got lost temporarily in space. And the Goldstone antenna emitted a radar signal, which then they detected with Arecibo to help to locate this spacecraft. And I stuck in a little note here at the end to build on something that David mentioned, the importance of this telescope for the island of Puerto Rico, not just as a premier research facility, but to promote science education in young people. I've been to Arecibo, I don't know, not that many times, 4 or 5, but every time I was there, every single day, the parking lot was full of school buses, of school kids coming from all over the island to visit, go to the visitor center, to tour the facility. And you really can't overstate the impact that it has for them. Very important. So, move on to the collapse. And again, I'll break this down a little bit, since at least on my screen it was all covered up. Who's to blame for the collapse? And as usual, there's plenty of blame to go around generally. I don't mean to single NSF out particularly. As David alluded to in his comments, the politics of the era were such that our national attention was focused on other pursuits, to put it kindly, instead of scientific research. But it really has an even longer history than that. And so I want to spend a little time talking about some of that in detail. I just today, in thinking about what I would talk to you all about, by sheer luck, I stumbled across this link from a person, Raquel Belho, who I don't know. She's on the faculty at Rensselaer and studies the sociology of science. I had a quick read of her posting. I wouldn't say I agree with all of it, but I agree with it fundamentally. And what I really like about this link is that she lays out very specifically what David was talking about how starting in 2006 or so, there was this 15% cut. And I mean, she explains very succinctly with specific data various points where Arecibo took a hit. And her basic point, though, is that we live in this culture, our research community has a constant tension between facility maintenance and scientific progress. And that affects lots of science areas, not just astronomy, but maybe it's a bit worse in astronomy than in some other areas. That if you build an expensive facility, then you have to maintain it, and that costs money. And after 10 or 20 years, you've skimmed the cream off of the discoveries, and science moves on. You want to do other things, and you need money to do other things. So you start to skimp on the facility maintenance. And to be fair, it's a challenge. It's, as David said, it was an engineering miracle. It happens to be located about 10 miles from the ocean. So there's a lot of salt in the air. Corrosion is a constant problem. You need regular, very good maintenance. And again, I don't mean to say that anyone at Arecibo was negligent, but they just didn't have the budget that they should have had to run an observatory like that and maintain it properly and continue to develop new instruments and so forth. But I'll note that this is not a recent problem. I mean, David mentioned 2006, I mentioned 2000 here, but when I was in grad school back in Wisconsin in the late 80s, early 90s, my research advisor is a well-known radio astronomer, and he was on an NSF committee that visited about half a dozen radio observatories, and their job was to decide which one they were going to close. NSF just didn't have the money to operate all of them, and so they were kind of the hatchet team to see which one was going to go down. And he told me at the time, it's between Haystack in Massachusetts and Arecibo. NSF is going to close one of them. And it turned out to be Haystack that was closed. Although at that point, the Air Force stepped in. Again, I'll get to the quantities of money that are needed and you'll in just a few minutes, and you'll see why this was not a problem for the Air Force. So thankfully, Haystack continues to live much better than it was at the time, in fact, thanks to the Air Force. But since the 90s, NSF has been looking to close Arecibo because they have these other newer facilities, more power facilities that they would like to pour their money into. And although I'm not sure it's true, it sounds reasonable, and I've certainly heard the story many times, that the reason they didn't close the observatory long ago is that evidently in the original legal contract that was written, there was a stipulation that if they decided to close the observatory, they would have to return the site to its original state. And that's a little bit ambiguous, what exactly was the original state. But if you take that to mean that you've got to put it back just like it was before anybody came and set a metal girder down, then that would be a very expensive undertaking. And so the general consensus is that NSF decided it was cheaper to keep it open and run it on a shoestring budget than to close it and put it back in the original condition. And so I think a big fault of reason for the collapse is just that it's had 20 years, not just 10 or 15 years. It's had 20, 25 years of shoestring budgets. And so it was inevitable that something like this might happen. Well, getting on a bit with the money then. I actually grabbed this slide and the next one out of a telecon I was on earlier today, which is for the next generation VLA. There's a project in process to replace the VLA, which has been around since the late 80s, mid 80s. So they want to do a new 260 antenna version of the VLA. And they're looking for money for it. Obviously, though, this will be an expensive proposition. And so one of the things they showed in the telecon today was this history from 1995 with projections to 2024 of the NSF astronomy budget. So this is just for astronomy, not, I mean, NSF covers lots of other things, but this is their astronomy budget. And as you can see, radio already takes up a pretty fair chunk of the total. And this doesn't include the next generation VLA either. So that, we can see the kind of brown down here would be the VLA, and Green Bank in the VLBA is the green, ALMA here is purple, and then the other things are mostly the optical telescopes. This DKIST is a new one, which maybe some of you haven't heard of. It's a new solar telescope that's going in Hawaii, named after one of their senators from, I think, back in the Watergate era, maybe, Daniel, I forget his name, but maybe some people with longer memories will think of that. So, but my point here in this slide is that if you look at the NSF budget for radio astronomy, we're talking in the, $50 to $75 million per year range, which is obviously a lot of money, but for the Air Force, they thought nothing of coming into Haystack and dropping $10 million on it. For them, for the Air Force, 10 million, that's nothing. That's chump change for them. And so really, I think what a lot of this comes back to is our national priorities for how we want to spend the money. So NSF, I mean, they have a hard task. I mean, they have a limited budget and they have to spread it over the entire range from radio through gamma rays. So I don't envy them their problem. Roberto Pájaro, John, since your Spanish is reasonable, you'll recognize that pájaro is a bird. West Virginia, when the 300-foot telescope fell down, had Robert Byrd as their senator, who had no trouble at all getting $55 million, which is what the original projected cost of the GBT was supposed to be. It ended up being 95 million because of various problems they ran into. But again, if you've got the political power, getting 50 or $100 million is not an issue. The money is there. It's just a matter of deciding how you want to use it. So, if the willingness were there to rebuild Arecibo, I'm sure it could be done. Whether it will happen or not is another question, because there are lots of other things going on besides Arecibo. In this graph, what I want to show you is the this MREFC. Yeah, I put it down here because I can never remember what it means. Major Research Equipment and Facilities Fund. So if NSF wants to build something new, it doesn't come out of this budget. An important point about maintenance, which I mentioned earlier, maintenance and operations, is that that money does come out of this budget. So what happens is they get some special money to build a big new facility, but then the section of NSF that built it, they have to maintain it out of their regular ongoing budget, which is a real weak point, I think, in the way the system is set up. So that the more facilities that NSF builds, the more of their regular money they have to spend to operate them, and then there's less money for other projects. But this graph is not just astronomy now. This covers all different areas. So like the LHCs, the Large Hadron Collider, high energy physics kind of thing. But you can see that here in 2021, 2022, some of these projects are scaling down because they're finishing. And so in the future, the question is, what's going to happen? You know, will the funding increase, and where will it go to? You know, some of it will probably go to the next generation VLA. Other people would like to have an extremely large telescope, an ELT, in the optical, and that would take a big hunk of this money. I mean, just the NGVLA is like the 500 million, 600 million level. So if we're spending that money on these other projects, will there be money left over for Arecibo or not? And here this window isn't that important. It's only $1.5 million. This is for a low frequency radio telescope that they're putting in California. But all of these projects have to come out of this budget somewhere. And so they're all competing with Arecibo for the money. And so to kind of close off my section of the talk, I just wanted to comment that whatever happens at Arecibo now, the decision that they make is not going to occur in a vacuum. There will be lots of factors that come into play. You know, political interests in Puerto Rico, other major facilities that NSF wants to build. In this picture, I'm showing the long antenna positions for the long baseline array. So this is also a new NRAO project. It's related to the next generation VLA. These purple dots would be the extent, well, the blue one here is the current VLA. The purple is where they want to put the new next generation VLA antennas. So it would cover from Texas over into Arizona and a little bit down here into Mexico. But the yellow dots, they also want to put some antennas in all of these positions as well. And this would kind of take over from the very long baseline array that NRAO currently runs. But you'll notice that there are some yellow dots here in Puerto Rico. So NRAO was already in discussion with Arecibo about the possibility of locating a couple of smaller antennas there in Puerto Rico. And, you know, those will cost probably $20 or $30 million. And so NSF may say, well, all right, Puerto Rico, we'll replace your observatory, but it will be done in terms of next generation VLA or the long baseline array, something that will serve a dual purpose, something like that. So lots of considerations that will be made before they take the decision. So I've talked long enough. I think I should open it up and have discussion amongst us all.
Thank you, Stan. It's great. Well, I just want to ask everybody, you started off, but it seems like we're neglecting some of the things. Planetary defense, education, museums, even the research. I think the voices for science, all of these voices are not being heard by the politicians. I've seen politicians come to scientific meetings. They look bored. Sometimes they go to sleep.
If I may observe, the replacement at Green Bank, the minute it was finished, they tried like hell to get rid of it. Because apparently the good senator had his senatorial way, but he sure got away with it. I don't think it would have been rebuilt if it hadn't been for him. I think I agree with you on that point. And so I personally, and I have no voice at all, not sanguine about the reconstruction of Arecibo. It may be a toss-up. Maybe they can redo the dish and put a slightly different feed, as you suggested, which would be a much easier feed to handle, much easier, for less than it would take to rebuild or to tear it all apart and kind of clean up. Hard to say, but I don't know. Hard to find them rebuilding it.
How much of the surface of the dish at Arecibo is, still reusable, and how much of it would have to be just totally replaced?
Bruce, looking at it, I got the idea that the majority is okay, but they may have lost its figure, So I think about, well, why not just we could survey it? We could answer that question by sending up a drone with a receiver, and we could build that without too much trouble, because the gain is so high. We would not have to use the big problem is going to be the noise problem from the motors on the drone. But we can actually see how it is now. It's certainly going to be a fuzzy image. Stan, have you seen anything in that? How much of the dish is functioning at the design specs?
No. When the first cable dropped back in November, it was not that bad.
You mean that's just the one in August, right?
August, sorry. Yeah, you're right. And I'm sure many of you have seen pictures of the surface. They lost maybe 5% of the surface at most. And that would not have been serious. They've had that kind of damage before to the dish and have repaired it without any trouble. But when the platform and the Gregorian came down, I'm sure that took out a substantial portion of the dish. And so I guess it's not like you'd have to rebuild the entire thing, but certainly it would all have to be refitted to the shape. And so, yeah, but don't trust me. Go online, and I'm sure you can find more accurate information there.
No, they're not really making the proper measurements, just like they did not make the proper measurements when the first cable failure occurred, in order to really evaluate the strength, longevity, the design, adheres to the design of the other cables. So it doesn't seem we have a measurement society. One goes out and makes the proper measurements to answer these questions. I almost think amateurs could do a better job answering some of these questions. Okay.
Another comment there, that if they put the let's say they put a Cassegrain feed up there, in the middle, which would seem like it'd be a much more reasonable thing to do, avoid 900 tons of having to be supported. You could support probably tens of tons and get a Cassegrain reflector up there. Wonder if supporting it with carbon fiber cables might be a practical thing to do. And the steel is basically, I think, mostly reflective of radio waves. Wonder if the carbon fiber would turn up being a noise source because it'd be at carbon at room temperature, or if it would be negligible.
Yeah, that's a thought, using modern materials. I hadn't even thought of carbon fiber. Can we I think it's still expensive, right? Carbon fiber is a difficult thing. I mean, I know we buy it for kayaks and arrows and sports equipment, but can we buy good cables?
Is anybody building bridges out of it yet? I mean, that would be your,
Yeah,
Good point.
but we don't have to. As I said, we can make measurements with drones. And we don't have to do the horrible thing of putting the receiver right on it, but a drone with carbon fiber or nylon string and can actually make measurements at L-band, and got a lot of signal strength there, and we can just see what the figure is, how much of the dish is still usable, or we can actually inspect it, I suppose, and come up with a good estimate. But I don't know that anyone is really considering these ideas. I know.
Oh,
as Stanley
part
said,
of the,
it's been talked to. Go ahead, Don. Sorry.
well, I'm sorry. I hardly know anybody here. I'm in SARA and been doing some amateur radio astronomy for a long time, just fussing around. But I think the whole thing has to be looked over to see how safe it is just sitting there right now. And so there's probably a big investment in an engineering study on which you would have to do even if you're going to take it apart. So somebody, it may sit there. Boy, it's hard to say what's going to happen with the present, with upcoming administrations. But I think the measurements you suggest would be easy, would be nice to make with a drone. That would be fun, in fact. But I think the mechanical stability has to be checked out thoroughly first. And then from there, because when I looked at the dish, it appeared to rip a streak right through the middle and then fell pretty much where the damage was from the August failure. But I think the big part of the budget will be removing that umpty-ump tons of feed and stuff. Then maybe one could look at what to do with reconstructing. I'm just blue sky, and it's hard to say.
Yeah, Don, one possibility would be to identify the areas that are faulty and consider those detrimental to function, and actually put an absorber over it. The absorber would unfortunately emit noise, but maybe it's possible to have something intelligent that wouldn't be so noisy. That would be less expensive than doing a repair. I don't know who to go to. I don't know who is, do we have a science advisor named for the White House yet? I don't think so.
That'll be the very last thing.
Well, I hope not. Yeah, probably. Well, hey, have any of you looked into what Sarah is saying? Has this been a topic in the Drake Lounge, or I sent something into the next Sarah newsletter. Is anyone else giving thought to what could be done to recover the function of Arecibo?
Not that I've heard. Not really. I think everybody's kind of stunned at this point.
Yeah.
The SETI League is probably more or as interested. They might have something, not SETI League, I'm sorry. The Institute, SETI Institute, might have something to say on the matter. I'm not sure.
So Drake is still there, and yeah, a lot of good people are still there, and they've got a good facility there in California, and I don't know what they're doing. Okay, well, I hope to see something improving about the situation. If any of you have ideas and want to send me an email, please do it. Any suggestions? If you want to publish anything about it in the our newsletter, you can send that to me, to Stacy Long, who's here. Don, I think we'll turn it back over to you. We have other things we could do in our program if no one else has any more comments.
I had one comment. I thought it was cool that in the Green Bank thing, after the dish collapsed and almost got the building too, they were smart enough to build a new dish further away. And that was a real brave move, just in case, I'll go back on mute now.
Yeah, good point.
Mr. Fields, what is the future of Arecibo? Because they've been doing some extraordinary work on asteroids. As I have a very good friend of mine, Lance Benner at JPL, that's made some outstanding contributions to the field, and they've taught us so much about minor planets, especially with the Earth danger possibility. Knowing more about our problem is something that should be right at the top of our list.
They've got a good project. Stan pointed out, I think, maybe he told me or something, that they had a lot of research going on, a lot of visitors, a lot of projects. It was being used. So if they repair it, it will be used. And but as far as the research, as far as the future with what's there now, I don't know. It needs to be, we need to find ways to restore as much of the functionality in many ways as we can.
One of my former classmates has told me that her active research there has been transferred to another telescope, but one that's just not as well suited for the purpose.
Stan, you've been involved with several of the projects and trying to help determine who gets what time. Is that what's going on? You see a lot of things shifting away, and how's that going?
Well, the radio community tends to self-isolate. People tend to either use the VLA a lot, or the Green Bank a lot, or ALMA a lot, but it's not that common that you find someone who uses all of those different facilities. And in the case of Arecibo, there are many young students, either undergraduate or graduate students, whose projects really needed Arecibo, and you can't do it with any other telescope. It's something that actually, when I'm working with students, I always caution them, well, whenever we start a project, like if a PhD degree depends on it, you need to have a plan A and a plan B, because what happens, I never think of a telescope falling down, but I think what happens if they don't approve our proposal for telescope time, then what will we do? And so a good advisor will always have a backup plan to protect the student in a case like that. But unfortunately, there are people who just get caught in the middle. In fact, I have one project going on now with Esteban Araya, who you saw in the pictures, and some Russian colleagues. We got half the observations done, and the other half obviously are never going to happen. So we'll have to sit down now and decide, what are we going to do? Are we still going to write the paper with only half the data, or will we just give up on it and call it lost cause?
Stan, are people being able to switch to the Chinese FAST telescope?
Not really. A lot of people, say, well, there was a bigger telescope that could replace Arecibo, but it's not the same. The geographical location is different, so the sky coverage is different. They don't go as high in frequency. I mentioned earlier the C and the X band were all of these molecular lines are. They can't do that with the Chinese telescope. Maybe someday, you know, when Arecibo began, it was a lower frequency antenna. It was in an upgrade that they could go to the higher frequencies. So FAST, the Chinese telescope, can pick up the slack for some of the projects, but not all of them.
Does FAST have any facility to do radar? In other words, to transmit the many megawatt signals kind of thing?
I'm not sure. David, do you know?
No, it has no
I think so.
transmitters at all.
No, there's another facility out on the West Coast. I forget where it is, but they've got some capability to do that, but it's very low power and not the resolution and pointing either. Goldstone, maybe? Is that it, Don?
Yeah, Goldstone can do transmitting.
But it's nothing like Arecibo. Arecibo is just so unique in many ways.
Yeah.
It was.
Very powerful transmitter there. Yeah.
Yeah, and I don't know how much of that, I doubt if much of it survived.
Mm-hmm. And again, this is the sort of thing that if the Air Force decides it's important to them to know what's going on in the ionosphere, they'll just spend the money and build something, you know. It's but if
They already decommissioned HARP,
Hmm.
right, which was an ionospheric research facility. So,
Stanley, what would it cost to actually totally restore the Arecibo well telescope? About $2 or $3 billion?
I do not know, but I would think it would be much cheaper than that. I would be surprised if it would cost more than several hundred million.
That'd be a small amount of money for NASA and government funding. But see, the one thing that you said that was so important was it is such a versatile instrument. People don't realize that.
If you were going to do something like Arecibo for a narrower frequency range today, you'd probably, rather than making a dish, probably go some kind of, flat filled aperture phased array or something like that. With the signal processing we have now that wasn't available in the 60s, 70s, and 80s, it would be more practical to do that. And whereas at that time frame when it was built, trying to bring together a few thousand antennas and process all the signals just wasn't within the computing capability.
Bruce, I think you're right in terms of the radar, but in terms of receivers, I think it's difficult, right?
Well, if you had a filled aperture, phased array, in other words, not like VLA, which is a sparse aperture with, very little fill, but in just the right place to get resolution. But a filled aperture, you'd have all the aperture there, so it'd be a very large number of elements in a phased array. But the phased array could get every bit the same sensitivities you could get with a large single dish. However, it's not as frequency versatile as a dish, but much less expensive to put up with the cost of digital signal processing having come way down.
Is that easy to do? The only one I know about that is like that, Stan's used it, I think. Stan, you've got that big array in Mexico, right?
Well, there's the large millimeter telescope. I think probably the best example of what you're discussing here would be the square kilometer array.
Yeah, it's more modern. Okay.
And that's that does exactly follow the concept that you're proposing. This large, small d, large n. So the diameter of the dishes is small, but there are many of them, and then you process the signal digitally to since I have several presentations on that, and I show a graph of the price of aluminum and steel over the last 50 years, and I compare that with the productivity of silicon in computer chips, which obviously grows exponentially. Part of the reason that my estimate, which again was just very off the cuff of a few $100 million, is that the original budget for the square kilometer array, which was to have a square kilometer of collecting area, their original budget was $1 billion, or €1 billion, I think, so a little bit more. And that's, they've had to scale it back because they don't have the money for it. But if 10 years ago they could build a square kilometer of collecting area for $1 billion, I would think that Arecibo could be done for a substantially lower amount.
I think the way Arecibo saves a lot of money is that the supporting infrastructure is still there.
That's right.
A lot of the facilities that are necessary to make the thing productive are there. Whereas if we would go somewhere else or build a different type of facility, it might not exist.
Definitely.
And none of the environmental stuff would have to be done. That's all been done already. You don't have to do any kinds of fooling around.
Impact studies and so forth, yeah.
Exactly. No impact studies, none of that kind of thing. And that consumes a lot of time and money.
Well, is there something we could do? We don't know where to send it. Is there something we should consider writing up and getting into the hands of the current administration? I don't think the educational part of it has any credibility at the moment, but it might in the future. The scientific world is trying to be heard, I guess. I guess we have to wait, but is there something we should be doing?
Anything I might say is off the cuff, okay? I'm thinking about an architectural engineer that will donate services to put something together. And what I would like to see, that would be perhaps in consideration, would be a dish. Of course, that one's got to be either rebuilt or a new one, but not on cables. Another way to manipulate it, but it'd be up like on a pedestal. There's
Getting for the secondary structure in the air might be somehow more agile. It might be made on might consider a tower rather than a cable support or something.
right, right. And all the controls would be from the ground. Just some ideas, but if anybody knows an architectural engineer who might have a little spare time to put something together, I think that would be a great start, because that's something you really would need as a starting place.
Kind of depends on how large an area the secondary must cover, and if it would be very localized, perhaps. But if it had to cover a large area in order to cover to reflect down the signal from much of the sky, it might be more difficult.
Oh, I see. Well, that's needs to be in the consideration, but some kind of a pedestal that's large enough to accommodate a large enough dish that can be manipulated from the ground. I'm just it would be really sleek.
Hey, David, I know I mentioned this to you earlier, I guess last week or whatever it was, the day after we heard about it. But I think because of the historic significance, it might work. I don't know. If somebody was to go and collect those cables and cut them into little, sell me a strand of that cable for $20, and that would go towards a fund to build a new dish. Now, you might just be able to get people to chip in $20 or $30 or $50 or whatever, to actually, get it,
So
get it moving.
There are places on the web, GoFundMe, or places to come up with innovative projects. And usually if you give something away, sometimes it's a t-shirt, but
Well,
might be a way to get some support.
you'd have a hard time getting 20 bucks out of me for a t-shirt, even though a t-shirt that covers me has got to be really big. I still think that because of the historic value, because of that Arecibo going so far back and in history, like what was it, the 60s or 50s it was built?
Yeah, 63.
Yeah, all right. So I mean that's significant, and that's why if it was a piece of that, I'd be willing to pay good money for that, and I think a lot of other people would too. Anybody that's interested in science might be willing to make a small contribution to have a piece of that, and that's why I think it would be worth considering.
I think it's a good idea to get public support. I don't know.
Myself, I think I'd want a piece of the dish surface, because that actually reflected the radio waves for all the different things that went on there.
Well, that's
the cable, it just held the stuff up, whereas that dish surface, the radio waves actually hit it and bounced off, so that would be even a little more significance. I'll throw in 50 bucks for a 6-inch square of dish surface. Take the stuff that's obviously scrap and can't be restored, cut it in 6-inch squares, sell it for 50 or 100 bucks, whatever. I'll throw in my money to get a piece of it.
Bruce, how many do you want?
The budget realities get to you.
He'll be giving you a piece of his aluminum siding.
Another thing people could do is join the Friends of Arecibo group. In the last week or two, they've had half a dozen telecons to organize, to do outreach and publicity for efforts to rebuild. And if anyone, I have an email, I'm on their email list. So if anyone would like me to pass that information along, I can do so.
Please share that, Stan. I believe you told me a few days ago they had 200 or so people.
Yeah, it grew very quickly, the group. There was a web link, which I will not be able to find right off the bat, but the person who sends out the emails about it, I don't think she would mind if I shared her email address with this group of potentially interested people. So I'll type that into the chat box. Joanna Rankin, she's on the staff at Arecibo, although her address is, I think, from Vermont, University of Vermont. So Joanna Rankin. So just drop her an email and say that you've heard about the Friends of Arecibo and you'd like to know more about it, participate. I'm sure she will respond. The one I'll paste now should be the link to sign up. Try that anyhow. I'll try it here and see what happens.
Okay, anybody else have any conclusion? Any thoughts? Don, do you have any, sort of mentioned this earlier, any astrophotos, or does Ted or anybody?
Yeah, I can show some things if you want.
Oh, wow. I wish you should have said something. No, because those are usually pretty good.
I mean, some of these I may have shown in some of our other board meetings or something, but I'll just run through them here. So this is, these are photos I've taken mostly in October and November. And of course, I've been taking pictures of Andromeda for some time, but I keep trying to get better ones. So this is my latest attempt at Andromeda. And then, of course, nearby Andromeda is the Triangulum galaxy. So I like to move over and take some pictures of it when I'm doing Andromeda.
All the red dots in the last one are hot pixels, is that right? Or are you actually seeing some?
Yeah,
red?
that's probably just noise that I have.
There are a lot of
and then, of course, this time of year, the Orion Nebula is quite easy to locate. The night I took this, there were some clouds moving in, so I didn't quite get the detail I would like yet, but I'll be trying some more pictures of Orion when I get some clear skies here. And then, of course, Orion Nebula is in the dagger of Orion, and then up closer to the belt is this NGC 2023, which has the Flame Nebula and the Horsehead Nebula. So I oftentimes go look at those when I'm doing the Orion Nebula.
Now, this is just a very difficult thing to capture with this beauty, I think.
Well, yeah, it comes through pretty. I have this this wide angle attachment, the Hyperstar that I use, that brings in a lot more light and gives me a wider angle that I can get these bigger things with. And it makes it so guiding is not quite so critical if you're looking at a wider region of the sky like this.
So what would you need to actually see it? A 12-inch scope and Arizona skies or something?
Yeah, certainly that would help. 11 or 12 inches would be good.
Yeah.
Tom, do you have a regular regime with certain filters that you're using all the time, or are you using different filters for different pictures here?
For some of these I have a Optolong L enhanced filter that basically just lets through the H alpha and the oxygen lines, I think, if I remember correctly. And so it gets rid of a lot of the light pollution. Now, it's better to use, I think for the galaxies, I'm not using any filter right now because the Optolong filter tends to kind of give the stars a funny color cast. The Optolong filter is best for emission nebula and nebula is what it's best for. So I've been using it for the nebula pictures. So this is the Pleiades, which you can usually see with your eye pretty well. Of course, Mars I did back towards the early fall, still kind of fuzzy, but and then the Veil Nebula is shown here. It kind of has two parts. This part, and then nearby is the Witch's Broom Nebula, which is shown here. And then a new one I've started looking at is the Bubble Nebula. And for it, I probably need to go to a narrower field of view to really get a good view of it. But you can see it looks just like this kind of spherical bubble there. So this is kind of the first time I've imaged it. I want to go back and try to do a little better job of it, but I was interested I could actually find it. And then this is the Cone Nebula, which is another new one I haven't done before. And that on the right over there is a picture from Wikipedia showing better quality, what it looks like. But and then there's just right above it, there's something called the Christmas Tree Nebula, which seemed appropriate for the season here. So it's a little hard for me to make out where the Christmas tree is, but I think it's actually inverted. It's an inverted Christmas tree, I think is what they say. But maybe with the Wikipedia figure on the right, you can see it better.
Hey, Don, I got a question about the preceding astrophoto.
Mm-hmm.
It was really, all these are really beautiful. But then the preceding one, there were two features, and one was
this one.
What? No, see this one. One is down in the lower left-hand corner. It's like a cluster.
Yeah, it's a cluster of some sort.
Is that the one, or is it the thing you were showing us? The bubble. Is the bubble the central whitish? No, the bubble's on the right. So what's the central whitish thing? Is that just an artifact? The central. To me, I see a large central feature.
In the bubble you're talking about, or?
No, the bubble's on the right, and then the cluster is on the left, lower left.
Yeah.
Exactly in the center, 3 times the diameter of the cluster is a white feature, a bluish white feature, like a cloud.
Yeah, I'd have to check on, I don't know what that is.
Okay, thanks.
It could just be some, maybe the color balance is out of whack or something. Yeah. But
Yeah, cool. Thank you.
anyway, that's what I've been doing. So.
Cool.
And then the other thing I guess I should announce here is this guy Stephen Ramsden I'd mentioned to you, David. I did get in touch with him, and he says he's willing to give us a program sometime next year. So he's I don't know if any of the rest of you know about, but every Friday morning, Skywatcher Telescopes has a kind of a 1-hour program where they talk about products or they interview somebody. So they'd interview this guy, Stephen Ramsden, and he specializes in solar astronomy, and he does lots of outreach activities. And also he talked all about how you can do spectroscopy even as an amateur. So I was interested in his interview, and I thought maybe he would be an interesting person to get for a program since we're doing things remotely anyway. And he's based in Atlanta. So I finally got through to him, and he said he would be willing to give us a program. So I'll have to set that up with him, and maybe early in the year sometime. But
That's great, Don.
so
Very interesting.
Thanks to you and and Juan for continuing to do the hard work.
yeah.
Well, thanks, Dan. Thanks, everybody. Night, all.